Okay, oh, wait a second. Okay. Yeah, so I did not draw number 3. I mean, I didn't need to, right? All you really need are 2, but I also do 3 just as a check. All right, so this is the ray tracing, yeah? And it's kind of interesting because according to the ray tracing, the image distance is exactly the same as the object distance, right? So the image distance is the object 40 centimeters. Okay? Now, all right, so that's our prediction, right? We get a real image, inverted, S prime equals S, so the magnification is -1, right? So now let's do the math. So let's just do it. Oh, what? Oh, okay, so here's the math. So 1 over S plus 1 over S prime equals 1 over F. So 1 over S prime equals 1 over F minus 1 over S. So again, S prime equals 1 over F minus 1 over S, -1. Okay, so the focal point is, the focal length is 20, right? The object is 40. You do that. You can do it in your head. Come on. This is 2 over 40. 2 over 40 minus 1 over 40 is 1 over 40. You flip it, you get 40. Bingo. So there you go. And the magnification is minus S prime over S. So it's minus 40 over 40, which is -1. So what do you know? So the ray tracing, we nailed it, right? We nailed it. That's pretty good. So you can do that if you're really careful with graph paper. Okay, let's do another one. Ugh. Ugh. Convex. Those are the worst ones. But you just got to get used to it. Convex. An object is 20 centimeters in front of a convex mirror with focal length of -20. Ray tracing. Ugh. We can do it. All right, so here is the mirror. Convex. And the focal length is 20, so I put here. The object is 30, so if this is 20, so here's 30. I made it big because I probably trial and error, you know. That's how it usually goes with these pictures. All right, ready? Here we go. So number 1, parallel in is going to reflect, but when you backtrack, it goes with the focal, right? Parallel in, focal out. So parallel in, focal out. There's number 1. Okay, I did number 3. I don't know why, I just felt like it. So number 3, that's the center of the circle. So just straight line. And of course it reflects here. Then 4 is the easy one. So just bing, bing. So this angle equals that angle. So you look at the outgoing. All right, so you have to backtrack. So we backtrack this guy, backtrack this guy, backtrack this guy. Bingo, there you go. So S prime is whatever, minus 12. And it's shrunk, but it's upright, right? So it's upright, and it's shrunk. So now let's do the math. Okay, so how many times are you going to see this, right? S prime equals 1 over F minus 1 over S, whole thing -1. Okay, see that minus sign on the focal length? So minus 1 over 20, minus 1 over 30, -1, you get minus 12. Hey, what do you know? We were pretty close, right? Pretty close, exactly. And then the magnification, 0.4. So notice it's positive, which is what we had, right? It's upright, positive, and it's shrunk. So there you go. So that's what's nice. You know, you have 4 rays you can draw. Just pick the easiest 3. You don't have to worry about it. All right. Okay. I'm going to leave this for you. So please do this. Yeah. Make sure you might have to just tape some pieces of paper together, but please do it. I mean, the answers are on it, but you need to know how to do this. If you can do this, you really, really, really understand lenses. Yeah, whoo, what a mess, huh? Well, no, I want to show you one point, though. I guess I just want to show you something. I was kind of hinting at it earlier, but now I want to explain it. All right, so ray tracing. Here's the object. Here's the focal points. So parallel in, focal out, they just go straight through. So here's the image for this lens, S1. Okay? So we can, all right, now let's do the math. So like we always say, I mean, there's nothing new here, you know. So we do the math, you get 30 centimeters. So from here to here is 30 centimeters, right? That's the image distance from the lens to S1 prime is 30 centimeters. But again, the image from this guy is the object for this guy. So great, this is 30 centimeters, but what do I want? In order to use the formula, I want to know remember, this is now the object for 2. So I want to know what this distance is, right? So how do I get this distance? Well, piece of cake. They will always tell you the distance between the lenses. So the distance between the lenses is 40 centimeters. I know that this here is 30, so that means that this is 10. Okay? So there, this is what I'm saying. For lens 2, S2 is 40 minus 30, which is 10. And then you just do the same old thing, right? So S2, but now we're working on lens 2, right? So S2 prime is 1 over the focal. I don't know where that's written somewhere. Oh, yeah, right there. 1 over 12 minus 1 over 10. You get minus 60. Okay? So that means that the object for this lens is 60 centimeters to the left of this lens. But remember, this is 40, so it's really 20, right? It's really 20 centimeters to the left of this lens. So here's S1 prime, S2 prime right here. But look at the magnification. So I did it this way. Magnification is M1 times M2. So here's the formulas, right? Minus S1 prime over S1, minus S2 prime over S2. The magnification is minus 12. So that means that this, so it's negative, so it's inverted. So this distance here is 12 times this. So like if this was 1 centimeter high, this would be 12 centimeters low, or whatever you want to call it. Okay? And apparently they gave us the initial height is 4, and so the final height is 48. Of course, it's inverted. So make sure you know how to do this. This is the part that gets people tripped up. You know, they calculate the image distance for S1, 30, and then they don't know what to do for the object distance for lens 2. But it's just a simple subtraction. Make sure you can do it. Okay, here we go. So understand the ray model of light where it's applicable. So what we said is if you shine light through a 1 centimeter hole and the image is about 1 centimeter, so there's very little diffraction, we're going to use the ray model. Reflection, refraction, ray tracing, this is wrong. We did that in the previous chapter. Okay, here you go. The law of reflection. Theta incident equals theta reflection relative to the normal. Plane mirror. S equals S prime. Virtual image. Perpendicular. This line is perpendicular with this line. Snell's law of reflection, right? So if you go from small n to large n, it bends toward the normal. If you go from large n to small n, it bends away from the normal. And again, here's the object, right? So it's n1. Here's the outgoing ray, so it's n2. But here's the object, so it's n1. Outgoing ray is n2. Got to be careful about that. Okay, then we did this crazy thing, right? The frog in the fishbowl or whatnot. Let's see. Okay, the three rays for converging lens. Parallel in, focal in, parallel out. Just go through the center. That's converging, diverging, parallel in, focal out, but you have to backtrack. Focal in, parallel out, but you have to backtrack, and then through the center again. Then that's, okay, then this is the equation for the fishbowl, or the fish tank. Then for the lenses, this is the equation. Make sure you understand what these things mean here. Okay, now our mirrors, right? Concave mirror. So it looks like, according to the object, it's a cave, concave. Parallel in, focal out, focal in, parallel out. Through the center of curvature. And then this is the nice one, right? It just reflects. So this angle equals that angle. Then for the convex, a bit more complicated, but not so bad. Parallel in, it reflects. So you backtrack it, focal out. 2, focal in, but it reflects here, parallel out. 3 is a nice one. Just goes right through the center of curvature if you drew that. And then the 4th one's nice too because it just in, out, where this angle equals that angle. And yeah. And this is the new thing, right, with the mirrors, that the focal length is the radius of curvature divided by 2. And you have these sign conventions again, which I'll give you. That's it. Thank you.